Hi, we'll talk today about rules of working with exponents. Let's start with the first rule. The first rule says when we have a to the power m, a to the power n, that would equal to a m plus n. So when we have a multiplication, we'll sum the power. Let's see an example. So if we have 3 to the power 2 multiplied by 3 to the power 5, that would equal to 3 to the power 2 plus 5, and that would equal to 3 to the power 7. Just notice here that 3 not changing, so the base is the same. Let's see property number 2. Property number 2 says if we have a to the power m over a to the power n, that would equal to a to the power m minus n. Let's see an example. So if we have 3 to the power 5 over 3 to the power 2, that would equal to 3 to the power 5 minus 2, and that would equal to 3 to the power 3. So notice that in multiplication we will sum the power, but in division we will subtract the powers. Let's see the next property. So property number 3 says if we have a to the power m all to the power n, that would equal to a to the power m n, so we will just multiply the powers. Let's see an example. So if we have 3 to the power 2 all to the power 5, so the result will be 3 to the power 2 multiplied by 5, and that would equal to 3 to the power 10. Let's see the next property. So property number 4 says if we have a multiplied by p all to the power n, we can write it a to the power n multiplied by p to the power n. Let's see an example. So if we have 3 multiplied by 4 all to the power 2, that would equal to 3 to the power 2 multiplied by 4 to the power 2. So basically we are just distributing the power. Let's see the next property. So property number 5 says if we have a over p all to the power n, we can just rewrite it as a to the power n divided by p to the power n. So basically we are just distributing the power here. Let's see an example. So if we have a 3 to the over 4 all to the power 2, that would equal to 3 to the power 2 over 4 to the power 2. So as you can see here, we are just distributing this power. Let's see the next property. So property number 6 says if we have a over p all to the power minus n, so the result will be p over a all to the power n. Let's see an example. So the example says if we have 3 over 4 all to the power minus 2, that would equal to 4 over 3, and the power here will be, instead of minus 2, it will be plus 2. So here we have 2. And basically we can just continue, so 2 will be distributed. So we have 4 to the power 2 over 3 to the power 2. And we can just calculate the answer. Let's see the last property. So property number 7 says if we have a to the power minus n over p to the power minus m, that would equal to p to the power m over a to the power n. So we are just flipping these values here and making the powers positive. Let's see an example. So if we have 3 to the power minus 2 over 4 to the power minus 5, we can just rewrite it as, we can just bring the 4 up and make the power positive. So it will be 4 to the power positive 5 over 3 to the power 2. So we are just making the powers positive and flipping the numerator with the denominator. Let's see example. So example number 1 says a x to the power 4, x to the power 7. So we are multiplying two same bases and different power. So we'll just plus. So we have x 4 plus 7, and this will equal to x to the power 4 plus 7 is nothing but 11. Part B says if we have y to the power 4, y to the power minus 7, so we will just do the same thing. So here we will have y to the power 4 plus minus 7. And we will get here y to the power 4 minus 7. And that would equal to y to the power minus 3. And we can just rewrite this as 1 over y to the power 3. We don't like the powers to be negative. We always love them to be positive numbers. Let's see part C. So here we have c to the power 9 over c to the power 5. So in division, we'll just subtract the powers. So here we will have c to the power 9 minus 5, and that would equal to c to the power 4. And this is the last answer. Let's see part D. So part D says b to the power 4 all to the power 5. So in this case, we know that we'll just multiply the power. So here we'll have 4 multiplied by 5, and that would equal to b to the power 20. Let's see part E. So part E says 3x all to the power 3. So we'll just distribute the power. So here we'll have 3 to the power 3, x to the power 3, and we can just simplify it. 3 multiplied by 3, it's 9. 9 multiplied by 3, it's 27. And the x to the power 3, we cannot simplify it more. Let's see part F. So part F says x to the power 2, x over 2 all to the power 5. So we can just distribute the power. So we can rewrite it as x to the power 5 over 2 to the power 5, and that would equal to x to the power 5 over 2 multiplied by 2. Let me just write it like this. So we have 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. So here we'll have, let's see, so here we'll have 4, and here we'll have 4, and here it's 2. So 4 multiplied by 4, it's 16. Multiplied by 2, it's 32. So let me just write it here. So x to the power 5 over 32. Or you can just say 4 multiplied by 2, that would be 8. 8 multiplied by 4, it's 32. Let's see example 2 part A. So here we have these two expressions multiplied by each other. So this expression here, we cannot simplify it more, so we'll just write it down as it is. And here we'll just distribute the power. So here we'll have 3 to the power 3, a to the power 3. Here we have b to the power 4, all to the power 3, so we can just multiply the power. So here we'll have b 4 multiplied by 3. This we'll just write it again as it is, b to the power 2, but this is 3 to the power 3, it's 27. 3 multiplied by 3 is 9. Multiplied by 3, it's 27. A to the power 3, b, we have 4 multiplied by 3, that would equal to 12. So let's see now. So let's combine the like terms. So here we'll have 2, and here's 27. So 2 multiplied by 27 is nothing but 54. And a and this a, we can just combine them. So we'll have a to the power 3 multiplied by a to the power 3. We'll just sum the powers. So we'll get a to the power 3 plus 3, that would equal to 6. And the final part, we have p to the power 2, p to the power 12. When we are multiplying the same terms, we will just sum the powers. So we'll get here p to the power 14. And this is the final answer. Let's see part b. So here we have x over y all to the power 3, so we can just distribute the powers. So here we'll have x to the power 3 over y to the power 3, and in this side we have y to the power 2 all to the power 4. So here we'll have y to the power 2 all to the power 4, and here we have x to the power 4, and here we'll have z to the power 4. Okay, so we can just simplify things here. So we have x to the power 3 over y to the power 3, and this part here, it's nothing but y to the power 8, because we are multiplying the power. Here we have x to the power 4, here we have z to the power 4. Okay, let's simplify things. So if you can notice here, we have y to the power 3, and here we have y to the power 8. So we can just subtract the powers, and here we have x to the power 3, and here we have x to the power 4. So we'll just multiply them and sum the power, and here we have z to the power 4, but it's just alone, there is no other z, so we'll just keep it as it is. Let's see. So x to the power 3, and here is x to the power 4, will be x to the power, we'll just sum them, so 3 plus 4 will be 7. And here y to the power 3, and here's y to the power 8, so we'll just subtract. So y to the power 8 minus 3, that would be y to the power 5. And z will be the same, so this z will be the same, so z to the power 4. Let's see example number 3, part A. So we have this expression and we want to simplify it. So to simplify it, we have to just make the like parts with each other. So here we'll have 6 over 2, and then we'll have s over s to the power minus 2, and then we have t to the power minus 4 over t to the power 2. So if you can just notice here that I am keeping the same variables with each other, but here we don't have a variable, so they are just numbers. So let's solve it now. We are just making the problem easier for us. So 6 over 2, it's nothing but 3 s to the power 1 over s to the power minus 2, so we'll just subtract the power. So here we have s to the power 1 minus 2, and here we'll have t minus 4 minus 2. Why? Because we have a division, so we have to subtract. So we'll get 3s to the power 1 plus, because we have minus and minus, it will be plus, so 1 plus 2, it will be 3, so s to the power 3, t here, we have t to the power minus 4 minus 2, that would equal to minus 6. Just in math, we don't like negative power, so to make it positive, we'll just bring it down. So the answer will be 3s to the power 3 over t to the power 6. Let's see part B. So we want to simplify this expression, so here we have a negative power, so we can just use the negative to flip the fraction. So we will get 3z to the power 3 over y all to the power 2. So I have used the minus to flip the fraction. So now we can just distribute this 2 here. So here we will have 3 to the power 2, z to the power 3, all to the power 2 over y to the power 2. So 3 to the power 2, it's nothing but 9, z to the power 3, all to the power 2, we'll just multiply 3 by 2, and we will get z to the power 6 over y to the power 2. And this is the final answer. This is the end of this video. Don't forget to subscribe, like, and share the video, and goodbye.